So in this question we read the extraneous solution to the equation here x over x minus 1 minus 2 over x equals 1 over x minus 1 is x equals, okay, well we've got to solve it first. The common denominator here looks to be x times x minus 1. So I'm going to put that in every numerator. So this first one's going to become x times x minus 1 over x minus 1 minus 2 x minus 1 over x equals 1 times x minus 1 over x minus 1. Now, bear in mind the whole time through here that the denominators here are going to spit out the non-permissibles 1 and 0. So x cannot be 1 or 0. Okay, I'm going to come back to that later on because I suspect when it says extraneous roots, my answer is going to be one of those two numbers. Well, it has to be one of those two numbers. Okay, so now here the x minus 1's cancel and I'm left with x squared. Here the 2x cancels. Sorry, not the 2x, just the x cancels, the two x's I suppose. And then I'm going to take that negative 2 and distribute it through. So it'll be negative 2x plus 2. On the right hand side the x minus 1's cancel and so we're left with just x here. And when you bring that over you're going to get x squared minus 3x plus 2 is equal to 0. Now to solve that quadratic I got to factor that. Now if you're not comfortable with factoring you can use the quadratic formula. Although if you just took a couple of minutes and gave that a good hard look here, you can only break up x squared as x and x, and because 2 is prime, it's got to be 1 and 2. So if this is positive and this is negative, they've got to be both negative. Negative 1, negative 2. So that's in factored form, and so x is going to equal either 1 or positive 2. Now, but the question was asking for the extraneous root. 1 is a non-permissible, so that makes it the extraneous root.